Okay, the new notes for today is that you got 9-4, and we're talking still area and perimeter, but this time we're going to talk about a rhombi. All right, remember that whenever we're doing rhombi, it's a parallelogram, okay? And but this is a special one because all four sides are going to be the exact same length. So what we can do is we can find the area by taking 1/2 times diagonal times diagonal. So what we normally say is that is diagonal 1 times diagonal 2 divided by 2. Okay, so now if we look at this, what is the length of diagonal 1 right here? Diagonal 1 equals 8. What is the length of diagonal 2? 3 and 3. Diagonal 2 is 6. Now, if I want to find the area, I'm going to just use that formula that's right there. I'm going to say area for a rhombus is going to be 8 times 6 divided by 2. 8 times 6 divided by 2. (24) units squared. So there you go. Now, to find the perimeter is a little tricky because we don't have what the side length is. So you're going to have to use those tools. The beauty that you got to remember about a rhombi is that when they intersect here, they make 90-degree angles. So you have a right triangle. Use your tools to solve this. And this is going to be a Pythagorean theorem problem. However, please catch on that this is a 3, 4, 5. This is the perfect Pythagorean theorem. It's in order, 3, 4, 5. And so we know that each one of these sides is 5. So the side length is 5 units, which means the perimeter would be 5, 10, 15, 20 units long. Okay. Here's one. We don't have a picture. Okay. We can find the area because it tells us that diagonal 1 is 10 and diagonal 2 is 20. Okay. So as we look at this, area is going to be fine. Area equals diagonal 1 times diagonal 2 divided by 2. 10 times 20 is 200. Divided by 2 is 100. So this would be 100 units squared. Okay. Now we don't have a side length. This is where we are going to have to draw a picture here to kind of help us out. So draw a picture of a rhombi. Remember that it's a parallelogram, and that sometimes it looks like a diamond, sometimes it looks like a square. But all of these sides are going to be the same. Diagonal 1, as we come through here, is 10. Diagonal 2, as we come through here, is 20. What you have to remember is that right here, it bisects each other. So the diagonal 2, that's 20, is going to break up to be 10 and 10. And diagonal 1 is going to break up. It was 10. It's going to break up to be 5 and 5. Okay? All of these angles are 90 degrees right here. You have to do Pythagorean theorem to solve this. You have a 5 and a 10. Okay? So off of this, I'm going to find this side here. This is really hard to see, but this is a 5, 5, 10. And I'm missing this piece right there. Pythagorean theorem. C squared equals A squared plus B squared. C squared equals 5 squared plus 10 squared. As I break this up, I know that's 25 plus 100. And so I get 125. Okay? I need to take the square root of this to counter it out. Once I do that, I'm going to use my calculator and see what happens here. The square root of 125. I hit enter. I get that long repeating decimal that I don't want anything to do with it. All right, I don't want that. So what I have to do is I have to simplify this 125. I'm going to go through that process again on my calculator, so make sure you're paying attention. Go to y equals. Okay, we got some people that have been using these calculators, and so I'm going to clear this out. Okay, so now for the y1, what I'm going to do is I'm going to type in 125 over x, and that's going to give me all the multiples of 125. 125 divided by x. I'm going to go to the graph, but I'm not going to hit the graph. I'm going to go second graph and pull up the table. Oh, Lord, somebody had this thing at negative 121. So I'm going to have to tab down a lot. So I'm gonna pause the video real quick and jump all the way down to where I need the picture. All right, we're back, and this is where we're at. 1 times 25, so these are all the multiples of 125. 1 times 125. Notice 2 doesn't work, 3 doesn't work. I get these decimal. Now 5 and 25. Here's the deal, is I am looking for the biggest perfect square, and I know that the square root of 25 is 5. So that right there is gonna be my biggest perfect square. And I could go on down here, and I could try to find some more multiples of this. And notice that all of them are decimals over here, okay, until I get to 25 times 5. So there's not a lot of multiples of 125. But I'm right here, right off the bat, I'm right where I need to be. 5 times 25. Last time I showed you how we broke this up, so I'm just gonna jump down to it. If we're gonna look at this as 5 times the square root of 25, we can break this up. The square root of 25 is 5. And we still have the square root of 5 that we will not touch. We'll leave it just like that. So the reason why we did this was to find out what the C was. C, once we simplified, was 5 square root of 5. That's the side length. And now we want to find the perimeter. Well, there are 4 sides that all have a length of 5 square root of 5. Okay? These are like terms. So if I want to do this, I can say the perimeter is going to be 4 sides that are all the same length of 5 square root of 5. 4 times 5 is 20, and then the square root of 5. So the perimeter is 20 square root of 5 units. Okay, as we flip over and we look at the next side, I have a rhombus here, 25, 25, 25, and 25. I could do the perimeter pretty fast. Side length, that's 25, and the perimeter is going to be 100. Okay, area looks really good first because the diagonal 1 right here is going to be 48. But I don't have a diagonal 2. What I am going to have to do is Pythagorean theorem to solve this. My C is 25. My A is 24. Now, fortunately, we just did this on the Are You Ready quiz, okay? So I'm gonna jump down to this, and whenever we do this and we subtract these over here and isolate our B, we end up solving this out to getting that the square root of 49 equals B. And the square root of 49 is 7. So if you need to take the time to actually work that all the way out and see that, go ahead and do that. But that's one side from here to here is 7, which means that this side is also 7. So that total length of that diagonal is going to be 14. Find the area. 48 times 14 divided by 2. And I'll just use the calculator for that. So let's get to 48 times 14 divided by 2. Area equals 336, and that'd be units squared. Okay, on the next one, we only have one little piece here, and that's 3. I know that this one here has to be 3, which gives me the total diagonal of 6. I'm missing this other stuff. I need side length. I need to know what this length is so I could double it and have what this diagonal is. So I have to use this 60-degree angle right here to let me in. All right, so this is a 30, 60, 90 triangle. Label it. After you label, x, opposite of the 30, opposite of the 60 is x squared of 3, opposite of the 90 is 2x. We need to look right here and find out that x equals 3. That's good. Not a lot of work to get our answer there. So now the side length right here, 2 times 3. 2 times 3 is 6. So each one of these has a side length of 6. The perimeter then, 6 plus 6 plus 6 plus 6, would be 4 times 6, which is 24. And that would be units. Okay, to find the area, I have to finish this part out. X square root of 3. Well, x is 6. So that means that one of these halves is 6 square root of 3. And the other half is 6 square root of 3. So the total diagonal here, if I add these two together, 6 square root of 3 plus 6 square root of 3, is going to be 12 square root of 3. So now if I want to do my area, diagonal 1 is 6 times diagonal 2, 12 square root of 3, divided by 2. Don't worry about that square root of 3. Just do 6 times 12 divided by 2. 6 times 12 is 72, divided by 2 is 36. So 36, we still have that square root of 3. That is our area, 36 square root of 3 units squared. All right, number 5, a rhombus has an area of 44 square centimeters. If the length of one of the diagonals is 11, find the length of the other. So just remember that area is diagonal 1 times diagonal 2 divided by 2. Plug in what you know. Area, 44. One of the diagonals is 11, so 11 times diagonal 2 divided by 2. We just worked a problem like this with the triangle. It's very similar. We want to counter our operations that are right here. Instead of dividing by 2, multiply by 2. If I do that to the right side, I have to do it to the left side. So I get 88 on the left equals 11 times diagonal 2 on the right. Now, undo this operation. Instead of multiplying by 11, we divide by 11. And 88 divided by 11 comes out to a nice even 8. Diagonal 2 is 8. And this would be centimeters because of that information right there.